It's recording.
He's ready for action. In 5, 4, 3. And welcome to another wonderful pre-calculus lesson with Mr. Wade.
And Sun Q.
And Steve Q over here. All right, this is lesson.
Lesson.
This is lesson 10-5. Okay, quiet on the set. This is lesson 10-5, and these are also known as. Very good. Oh yeah, live studio audience, by the way. You can hear them in the background. Okay, now, let's do this. First equation is f of x equals 5x cubed plus 15x squared minus 45x. Gee, I wonder what that is. Snake. Not a W. A W is when you have a fourth power of the square root, okay? As they say in the South. Right? But this is a snake with a
camel. That's got like a camel.
However you want to remember, just remember what it looks like. Okay, so snake with a bend. All right, now let's do this. Step 1, we're going to do a first derivative test, so we will take the first derivative. All right, first derivative would be 15x squared plus 30x minus 45. Okay, and of course our first instinct is to always set it equal to 0 and try to factor it. Right, that's right too. Okay, now remember. Get it equal to 0 first when you have to solve an equation. However, this is the shot of the playing board and nobody's there. However, yes, we lost the host. Okay. However, once you get something equal to 0, before you just factor, always try to factor what?
The greatest common factor.
Greatest common factor, that will help you so much. I don't want to factor this into 2 parentheses. You kidding me? Hey, take out a 15. I bet you it's handcrafted. Hey, let's see. Oh, yes, Mr. Wade, I see now. Okay, yep. Okay. See, if you do the things that I tell you to do in class, then you'll get to these levels where it's like, oh, this is handcrafted just for me. Okay, I'm doing very special. All right, I see you, Mr. Wade. I feel you. Okay. Get this right here, you're like, yeah, I got you, handcrafted. Okay, see? And if you don't factor that out, you're like, I don't know what's going on. Okay? All right. So, let's factor that into what? X, sure.
Plus 1 and minus 3.
All right, let's see. Plus 3, yeah, plus 3 minus 1. Oh, look at this. It all comes together. See that? Okay, I got you, Mr. Wade. Okay, see? When it happens, it's so nice. Yeah, just don't say it out loud.
No, then everybody else. I got you, Mr. Wade.
Okay, all right. Okay, now, step 4. Is there a D&E case today?
No.
Gee, Stephanie, right? Doesn't look like there's a D&E case today because there's no
Denominator
okay.
X.
No. Yes, very nice. Very good.
I already got it too,
So that would be a big fat no.
Well, I did the denominator.
Okay. Now, are there any critical numbers?
Yes.
Yes. Okay. Well, first of all, 15 equals 0. 15 equals 0.
No.
I see people do that from time to time. They put it as 0. Well, no, 15 can't be equal to 0. Okay. However, from these two, you get solutions of
Negative 3 and 1.
negative 3, positive 1. Check. All right. Got that. Okay. Now, step 6. Let's construct the first derivative test. And I have labeled my number line f prime to avoid losing mega points. Right there.
So it's okay to like just do the letter that's given.
Right, yeah. Or then you can put y prime too. That's fine. Because in general, it's y prime. Or you do that. Okay. So put something, right? And then we will label this as, now who's smaller here?
Negative
3 is smaller, comes first. 1's bigger. Now we can pick sample points, and here you can have a little bit of creativity. If you like English better than math because you have more creativity, well, here's your chance to show some creativity right here. All right? If you like Mr. Wade, you like math way better than English, then hey, probably a lot of you in here. Probably most of you. Oh, and that too. I got both. Mom and Dad fused together. Okay. So, anyways, what we have to do here is this. Let's pick something below negative 3, such as.
Negative 100.
Okay, negative 1,000, negative 100, negative something. Give me something good. Between the two, 0 is always a good one to pick. If you could pick it, I would pick it. Okay. And then bigger than 1, Okay,
5,000.
100.
okay,
100
1,000,
million.
100 million, 500, 5,000, whatever you want, right? Doesn't matter. Okay, now let's take all this stuff and let's plug it in.
89,242.
Now, let me show you what we did last time, okay? The first time we did this, we said, let's take negative 1,000 and put it in here, here, and there. Let's take 0, put it in here, here, and there, okay? But the way a mathematician would most likely do it is this.
One
Kind of way we
trillion.
prefer. Just do one group at a time, and it's kind of faster that way. Okay? It's your choice, okay? But if you just look at the 15, put in negative 1,000, put in 0, put in 1,000, put in a billion, it's always 15. It's not affected by x, so it's always positive, right? So I already know that the first one's going to be plus on all these. Okay? All right, so far so good. All right, now let's focus on the middle parentheses. Negative 1,000 plus 3. What do you think about that? Okay, obviously negative. 0 plus 3. Oh, there you go. Middle parentheses just changed right here.
That's a value.
You know what? You remember from last week? As soon as you transgress the root, if you will, then you could get a sign change. Not always, but you could get a sign change. If you're not transgressing your own root or passing your own root, there's no way you can get a sign change. Okay? Now, bet you this one won't change. You know why? Because 1 is not the root of this parentheses. Guess what 1,000 plus 3 is? It's positive. Okay? How about that? Middle changed, stayed the same. Going around its own root. Okay? All right, now, try this one. Negative 1,000 minus 1?
Negative.
Negative. 0 minus 1? Good change. Oh yeah, negative 3 is not the root of this parentheses. But wait. 1,000 minus 1? There you go. Okay? All right. So, you get a plus, you get a minus, and you get a plus.
I'm so surprised.
First derivative is always slow. Okay? Boy, that's a shocker, kids. All right? I'm so surprised. Of course I'm not. We promised a snake with a bend, and sure enough, the original function is increasing until you get to negative 3 comma we don't know. Then it's decreasing until you get to 1 comma we don't know. And then it is increasing. And that's just a generic, just draw the jagged on the number line test, but that's a generic up, down, up snake. Okay? Right, yeah, it's smooth. It's smooth. But when you do your sketch, just do like a jagged sketch really fast to get it in your mind what's going on there. That helps. Okay? You don't have to make it. All right, so that's that. Now, let's answer some questions. Okay, does f have a maximum value?
Yes.
Do you remember what maximum value is from last week?
Positive infinity.
Infinity.
How high?
That is,
Say how high.
The highest point. Oh, the highest point in the local area.
so how high basically, right? But the word value only refers to
Why?
y coordinate. Okay?
Oh, we got all wrong.
All right?
How tall is it?
We, yes, exactly. Remember last week? Yes.
I wrote that
Yeah.
down, so.
Here's a bonus question for you. How tall is Mount Everest? Nepal. Right. Good one. Right? That's where it is. That's not how tall it is.
The
Okay?
fact that you know where Mount Everest is.
Well, that's impressive. Yeah. I'll take Nepal or Tibet. It's like right on the border. Okay? But guess what? That's where. That's like the x-coordinate. The x-coordinate tells you where it is, or if you give the GPS of Mount Everest. Okay, that's where it is. That's all fine and dandy. How tall is it is the y-coordinate. Okay? You're supposed to give me 29,029 feet and a centimeter or so. Okay? So, in this problem, I only want the y-coordinate. All right? So, the max value would be, is there one at all?
Infinity.
Okay? Well, this one goes up forever, so there actually will not be a highest point, right?
Yeah.
No highest y-coordinate, we could say. Okay? Doesn't happen here. Now, the gist of this first page here today is that I'm going to block it off at an interval where you will have a high. Okay, that's going to change this. Okay? Does f have a maximum value on negative 5 to 0?
Yes.
Okay? So let's block this off at negative 5 to 0. Picture this over here. Negative 5 and 0, don't they surround the 3, the negative 3? Okay? So if you surround negative 3 with negative 5 to 0, wouldn't it kind of look like up, down? Make sense? Okay. And what's this place right here?
Negative 3, 0.
Okay, negative 3. So I'm just blocking this off. Is there a high point here?
Yes.
Yeah.
There is, absolutely. You will actually learn next year in calculus a theorem that says that if you take any function that is continuous and you block it off on a closed interval, there's guaranteed to be a high place and a low place, for sure. There's the high place right there. And as a matter of fact, the low place would be a competition between which endpoint is lower. That would be the lowest, okay? All right, so that's a yes, okay? And by the way, it is at x equals -3, but what it asks is for the maximum value. Okay, how tall is that peak?
The pop.
I got, yeah, the ball. I got the GPS coordinates, yeah, so what? Okay, I want to know how tall it is, so where do you stuff that -3?
The original.
Only into the original function, because the only thing the original function is ever good for is finding y coordinates. Okay, so you take that, I'll save you some time, you stuff it back in. And by the way, it would behoove you to do several things here. It would behoove you to factor out a -3. Because all those x's in the original function are going to turn into -3, so I would just factor that out. And also, how about 5, 15, and 45? Can you at least take a 5 out of all that? And the more you take out, the easier it is. Okay? So I'll cut to the chase. You factor some stuff out, you crank it out, you get 135. Okay? And that would be the highest right. So you don't have to have a maximum value on a graph, but you do have to have a maximum value on a closed interval. Right?